So dear students, in the last video we discussed about the definition of a function and algebra of functions. Okay. So a function is a relation between two non-empty sets A and B, okay, such that every element of A is used as a pre-image and no element of A is repeated as a pre-image. That means the first component. Okay, that was the definition of mapping or functions. Okay, generally we represent a function by y equal to fx. Here y is called the image of x under f. Okay, and what is domain? The set A itself is called the domain. In A there lies the values of x. So in other words, we may say that the values of x are called domains. Okay, and in the set B, some elements are used as the values of y. That means the images, and the set of images is called the range. Okay. Now we try to redefine domain. What is domain? Domain is the set of values of x for which the function is defined. And what is range? Range is the set of values of y for which the function is defined. Okay. Now, what does the word define means? Okay. First of all, in our higher secondary syllabus, all the functions are considered as real functions. Okay. So, first condition is the values of x and y must be real values. Okay. Real functions means the functions whose domain are subsets of the set of real numbers, and range are also the subsets of the set of real numbers, are called real functions. Okay. So our values of x and y must be real. Okay. Now, what are real numbers? All those numbers that you know are real numbers. Naturals, whole numbers, integers, rationals, irrationals, all are real numbers. Only those numbers, that means radicals of negatives. Radicals of negatives. That means root over minus 4, root over minus 3, root over minus of something is not a real number. Okay. So basically a function becomes undefined when some negative quantity comes under square root. Okay. There is one more chance. Suppose fx equal to, let me discuss with some example, fx equal to 1 by x. Okay. So where will the functions be undefined? What do you think? If there is no radical sign, so square root of a negative will not come here. But if I take the value of x as 0, if I take x equal to 0, what will be the value of fx? That means the y. What is y is fx, and what is fx is y. So if I put x equal to 0 here, what will be the value of y? 1 by 0 is undefined. It's not a finite number. Okay. So in that case also a value becomes undefined. That means it's no more a real number. Okay. So in general, in two cases, a function becomes undefined. Whenever something comes negative of a square root, when it becomes negative of a square root, it becomes undefined, and whenever the denominator becomes 0, it becomes undefined. That means it's no more a real number. Okay. Now, if I say fx equal to root over x minus 4, so when will the function be undefined? Whenever this quantity x minus 4 is negative, the function will become undefined. Okay. X minus 4 is less than 0, then the function will become undefined. Now if I take fx equal to 1 by under root 2 minus x, when will it be undefined? Whenever the quantity 2 minus x, it is under a radical sign, so whenever it is negative, the function is undefined. It is in the denominator, so whenever it is 0, the function will be undefined. Okay. So while finding domain and range of a function, you are to consider these two facts in your mind. Okay. Now, let us start with some example. Let the first example be this. First of all, we learn to find the domain. Our question will be like this: find the domain. Find the domain of the function or mapping. Okay, the function or mapping. Let the first example be fx equal to under root 1 minus x squared. Okay, so when will this be undefined? The given solution, we will write like this: the given function is undefined, if, when will it be undefined? Whenever the quantity under the square root becomes negative. So if 1 minus x squared is less than 0. Okay. Now we factorize it. So this can be written as 1 plus x into 1 minus x less than 0. Now you find the 0 of this polynomial 1 plus x into 1 minus x. What are the zeros here? So this quantity will be 0 if x equal to minus 1, and this quantity will be 0 when x equal to 1. So there are two zeros, minus 1 and 1. So you put these numbers on the real line, minus 1, 1. Now this is our real line. Real line means minus infinity to plus infinity. So there are three parts of the number line. First part, minus infinity to minus 1, that means less than minus 1. Then minus 1 to plus 1, then plus 1 to infinity. Okay. So we have got three parts of the real line here. Okay. After putting the zeros on the real line, we will get some parts of the real line. Now you want to check sign of this expression 1 plus x, 1 minus x in each of these parts. Okay. So if, let us take the first part, x belongs to minus infinity to minus 1, minus infinity to minus 1, that means in this part. So here the value of x is less than minus 1. You consider any value less than minus 1 and put it in this expression 1 minus x into 1 plus x, this expression. Okay, or 1 plus x into 1 minus x. Okay, 1 plus x into 1 minus x. So you take any value less than minus 1, say minus 2. Okay, you put minus 2 for x. What will be this? 1 minus 2 into 1 minus minus plus 2. So this quantity will be negative. It means throughout the whole interval, this expression 1 plus x into 1 minus x is negative. Okay. Now check it in this part, minus 1 to plus 1. Try to find a number in between minus 1 and plus 1. Okay. We know 0 lies in between minus 1 and plus 1. You take 0. So this will be 1 plus 0 into 1 minus 0, which is 1, that means positive. Okay. Then greater than 1. 1 to infinity means greater than 1. You take any number greater than 1, say 3. Okay. You put 3 for x. 1 plus 3 into 1 minus 3. That is equal to 4 into minus 2, which is negative. So the expression will be negative here. Okay. So 1 plus x into 1 minus x is negative. In which intervals? This and this. So we write, this implies x belongs to minus infinity to minus 1 union, minus infinity to minus 1 union, this part positive, so leave it, 1 to infinity. 1 to infinity. So our inequation is 1 plus x into 1 minus x less than 0. This type of expressions are called inequations. So our inequation is 1 plus x into 1 minus x less than 0. That means the quantity 1 plus x into 1 minus x is negative. We have to check in which intervals this quantity is negative. We found that it is negative in minus infinity to minus 1 and 1 to infinity. So either this interval or that interval will be the solution. So all these union, so we have taken union. So x is negative means minus infinity to minus 1, union 1 to infinity. Negative means undefined. So x is undefined in this interval. Now we are supposed to find the domain. What is domain? Domain is the values of x for which the function is defined. So where is the function defined? In this interval it is undefined, this interval it is undefined. Okay. So minus infinity to minus 1, open interval. So just before touching minus 1 you will stop. Open interval 1 to infinity, just after 1, then up to infinity. So here it is undefined. So here is it defined? It is defined from minus 1 to plus 1, including minus 1 and plus 1. Therefore, the function is defined. Function is defined in where closed interval minus 1 plus 1, including the boundaries means closed interval minus 1 plus 1. So wherever the function is defined is the domain. Therefore, the domain is closed interval minus 1 plus 1. Alright? Okay. Next, let us take another example. Say fx number 2, fx equal to under root 4x minus x square minus 3. Alright? So the given function is defined. The given function is defined if when the function is undefined, the given function is undefined if 4x minus x square minus 3 less than 0. So the function will be undefined if this quantity is less than 0. This implies to make it positive, x square minus 4x minus plus 3 less than 0. And now there are two rules for inequality. A greater than b implies minus a less than minus b. Whenever sign changes, inequality changes. There is a rule of inequality. Sign changes, inequality changes. There is one more rule. A greater than b, 1 by a less than 1 by b. That means the ratio changes, inequality changes. Ratio changes, inequality changes. Here we will change sign of both sides. X square minus 4x plus 3. So this will be greater than 0 because sign changes, inequality changes. Now we make middle term factorization of this quantity. X minus 3 into x minus 1 is greater than 0. Now we find the zeros of this polynomial. What are the zeros? This part will be 0 if x equal to 3. This part will be 0 if x equal to 1. So 0 of the polynomial are 1 and 3. You put the values on the number line. 1 and 3. Okay. So it divides the real line into 3 parts. Minus infinity to 1, 1 to 3 and 3 to infinity. So we have to check where among these intervals where the function expression, this polynomial is positive. Okay, let us check the signs. Minus infinity to 1, 1 to 3 and 3 to infinity. First part, minus infinity to 1. That means less than 1. You take any value less than 1, say 0. Our expression is x minus 3 into x minus 1. You put 0 for x. So this will be 0 minus 3 into 0 minus 1. So how much is this? 3, which is positive. So throughout this interval, the value will be positive. Okay. Then you take any value in between 1 and 3. Here it will be negative. If in this part the function is positive, in this part this will be negative, in this part it will be positive again. Okay, let us take. So 1, 2, 3. You take any value in between 1 and 3, say 2. 2 minus 3, 2 minus 1. So minus 1 into 1 is negative. Again in this part it will be positive. Let us check. 3 to infinity. Any number in the interval 3 to infinity, say 5. So 5 minus 3 into 5 minus 1. Okay, 2 into 4, 8, which is positive. So the function will be positive here. So the expression becomes positive in this interval and in this interval. So the solution will be x belongs to either in this interval minus infinity to 1 or in this interval 3 to infinity. So greater than 0, when it is greater than 0, when the function is undefined. When the function is undefined, where, that means where the function is undefined in the interval minus infinity to 1 union 3 to infinity. Then where it is defined, you leave the undefined portion, you will get the defined portion. So we leave minus infinity to 1 open interval, 3 to infinity open interval, then there remains 1 to 3 closed interval. Therefore the function is defined in closed interval 1 to 3. And what is domain? Domain is the set of values of x for which the function is defined. For which set of values of x the function is defined? The function is defined for the set of values of x which lie in the closed interval 1 to 3. So this interval is the domain of the function. Therefore, the domain is closed interval 1 to 3. Alright? Let us take one more example. One by root over 9 minus x square. So given function is undefined. If when it is undefined, well 9 minus x square under radical sign, so when it is negative, again it is in the denominator, so it will again be undefined when it is 0. So it is undefined when 9 minus x square is less than or equal to 0. Less than 0 means negative. So it will be undefined if 9 minus x square is less than or equal to 0. This implies, let us change the sign, x square minus 9, we will always try to take x square as positive, x square minus 9 less than 0. Remind it, always take x square as positive. This will help you solve the inequation. So sign changes, inequality changes. Now we factorize x minus 3 into x plus 3 greater than equal to 0. Now you find what are the zeros. This part is 0 for x equal to 3, this part is 0 for x equal to minus 3. So the zeros are minus 3 and 3. So the zeros are minus 3 and 3, which divides the interval into 3 parts. Minus 3, minus infinity to minus 3, minus 3 to 3 and 3 to infinity. We are to check the sign in these 3 intervals. Okay. What is the expression? X minus 3 into x plus 3. Okay. So in the first interval, minus infinity to minus 3, you take any value in between minus infinity and minus 3, say minus 4. Say minus 4. Okay. You put minus 4 for x, minus 4 minus 3 into minus 4 plus 3 means positive. Multiply. This is a positive quantity, so throughout the interval, this expression will be positive. If it is positive here, then it is negative here and positive here. Okay, you may check it. So, in which intervals the function is positive? The function is positive minus infinity to minus 3 and 3 to infinity. But here is one more thing. It may also be equal to 0. Whenever it is equal to 0, it is also undefined. Where it is equal to 0, it is equal to 0 at the point minus 3 and 3. So, the function is undefined in the interval minus infinity to close to minus 3, because equal to sign is there, and from 3 to infinity. So this interval and this interval. So x belongs to minus infinity, you may take this bracket, minus 3, minus 3 is closed, union 3 to infinity. So in this interval the function is undefined. Okay. So minus 3, for minus 3 it is undefined, for plus 3 it is undefined, and it is defined in this region. Okay, the remaining part. So what is this region? Open interval minus 3 to 3. Therefore the function is defined in open interval minus 3 to 3. Why open? Because at the boundary points the function is undefined. It becomes 0. And when it becomes 0 it is undefined. Okay. So this is our domain. Therefore the domain is this. Alright. Let us take one more example. Number 4, fx equal to x into x minus 1. Okay. So when will the function be undefined? Okay. Here is no radical sign, so the question of negative does not come here, but some quantities are in the denominator. So a function becomes undefined when the denominator becomes 0. So this function will be undefined whenever this quantity is 0. Okay. So we take in this way. The given function is undefined if x into x minus 1 equal to 0. Okay, only 0, no less than, no greater than, because no radical sign is here. Okay, this implies x equal to 0 or x equal to 1. So function is undefined only at the points, only in at this. Sorry, let us mark it. Okay, which points? One point is 0 and one point is 1. So only at these 2 points the function is undefined, and in all other parts the function is defined. So what is our domain? The defined part is our domain. So our domain is the whole real line only leaving these 2 points. Okay. Therefore the domain is from the whole real line we leave only these 2 points. How we leave? Minus 0, 1. Okay. So this is the domain. Alright. And the last example. Fx equal to 1 if x is rational, 0 if x is irrational. This is another form of defining a function. Fx takes the value 1 whenever the function is rational, and takes the value 0 whenever the value of x is irrational. So x is taking both the rational values and the irrational values as per the definition. As per the definition, x is taking both rational and irrational values, both q and q complement. Okay, that means the domain, it is defined for both q and q complement. That means the domain is q union q complement. And what is q union q complement? Q union q complement is the set of real numbers R. So without any discussion we will write here the function is defined for all real values of x is defined for all real values of x. Therefore, domain is the set of real numbers R. Okay, set of real numbers R. Okay. Now there are some special type of functions like log x, sin x, cos x, that means the transcendental functions. Okay. Now if you are asked to find the domain of the function fx equal to sin x, okay, you will get it later on, we will discuss later, but here let me say you, sin is defined for all real values of x. So sin x is defined for all real values of x, so the domain will be the set of real numbers. Fx equal to log x. Log function is defined only for positive real values of x. Okay, log function is defined only for positive real numbers. Okay, so what will be the domain of this? Positive real values. Okay, that means this is defined for x greater than 0. So what will be the domain? The domain will be, here 0 is excluded, so open 0 to infinity, greater than 0. Just leaving 0, all the right side you have to take. Okay. So this is all about domain. Try to do the homeworks. Now we will discuss about range. So what are range? Range is the set of values of y for which the function is defined, or set of real values of y for which the function is defined. Okay. Let's start. First of all, number 1, let fx equal to under root 1 minus x square. Okay, we are to find the range of this function. Range means what? Set of values of y, but not no y is here. Okay, but we know whatever fx is y equal to fx. So what is fx is y. Let us clear it here. Let y equal to fx equal to root over 1 minus x square. Okay. So we are to find the values of y. So we are to express x in terms of y. We have to express x in terms of y. While finding the values of x, we had written y is equal to some function of x. Now we have to find the values of y. So we have to write x as a function of y. Let's see. This implies, that means you are to find x from here. 1 minus x square. This implies x square equal to 1 minus y square. Alright? This implies x equal to plus minus root over 1 minus y square. Okay, is this correct? Plus minus root over 1 minus y square. Or should I write only this? No plus minus, just root over 1 minus y square. No, I have to write plus minus 1 minus y square. Okay. If I write only root over 1 minus y square, this would mean only the non-negative values, no negative values. But it may take both negative and positive value. So we have to write plus minus. Okay. So which is undefined if whenever it is undefined 1 minus y square is less than 0, because this is under radical sign. Now you have to make y square positive, y square minus 1 greater than 0. Sign changes, inequality changes. Implies y plus 1 into y minus 1 greater than 0. Now what you have to do? You have to find the zeros. What are the zeros? Minus 1 and plus 1. Okay. Put the zeros on the real number line. Minus 1, plus 1. So up to infinity from minus infinity. Alright. Now you have to check sign of this quantity on these 3 parts. Alright. Procedure is almost the same. So what is our expression? Let us write it here just for checking. So you are to take any value on from this interval, minus infinity to minus 1. Suppose minus 2. You put minus 2 here, minus 2 plus 1, minus 2 minus 1. So what is this? This is positive. Minus 1 into minus 3 is plus 3, that means positive. If it is positive here, then negative here and positive here. Okay? First part positive, second part will be automatically negative. You may check it. And third part will be positive again. The function will change sign on each part. Okay. So what is given here? Greater than 0 means positive. We have to find where the function is positive. So where the function is positive in this interval and in this interval. So the solution will be y belongs to minus infinity to minus 1 union 1 to infinity. Alright. So in this region the function is undefined. So where is it defined? It is defined in this region. Closed interval minus 1 to plus 1. Why closed interval? Because minus 1 plus 1 are not taken here because no equal to sign is there. Okay. Therefore, the function is defined. The function is defined for y belongs to closed interval minus 1 to plus 1. Okay. But in case of range, we have to remember one more thing. You see, here fx equal to under root 1 minus x square. What is this value? Positive or negative? You see, whenever it is negative, we have to consider a minus sign before the radical sign. Okay? Root x is always a non-negative quantity. Okay? If it is negative, you have to give a minus sign here. Root x is always a non-negative quantity. Alright? So, root x is always a non-negative quantity. So, value of fx cannot be negative. But y is given to be non-negative. We write it here, but y is given to be non-negative. Non-negative. So where is the non-negative part? We have got minus 1 to plus 1 as the solution. Okay. But y is given to be non-negative. That means y cannot be negative. So we have to leave the negative part. Up to 0, up to this, before touching y. Y is negative here. So what remains? 0 to 1. Therefore the domain is closed 0 to 1. Alright? Sorry, not domain, this is the range. Therefore the range is closed 0 to 1. Alright? Let us consider the second one. Number 2. Fx equal to 1 by root over 9 minus x square. Okay? 1 by root over 9 minus x square. So, just like the previous one, you are to consider y. Let y equal to fx equal to 1 by root over 9 minus x square. Now make square, leave it. Y square is equal to, you won't consider this part, 1 by 9 minus x square. Okay? Then 9 minus x square is equal to 1 by y square. Then 9 minus 1 by y square is equal to x square. This implies x square is equal to 9y square minus 1 divided by y square. Okay? This implies x equal to plus minus under root 9y square minus 1 divided by y. Okay. Okay, so this is the value of x. So this will be undefined, which is undefined if, when it is undefined, here is a radical sign, so it will be undefined if 9y square minus 1 is less than 0. Again, y is in the denominator, so it will again be undefined if y equal to 0. So for radical sign, 9y square minus 1 less than 0, and for denominator, y equal to 0. Now you have to factorize it. Thrice y plus 1 into thrice y minus 1 less than 0, y equal to 0. For both the conditions, the function will be undefined. Now what you have to do? We have to find the zeros. So what are the zeros? Thrice y plus 1 equal to 0 means y equal to minus 1 by 3. Minus 1 by 3. Then thrice y minus 1 equal to 0 means y equal to 1 by 3. So the real line is divided into 3 parts. Okay. So we have to check the sign in these intervals. Sign of which? This quantity. Thrice y plus 1 into thrice y minus 1. Okay. So in this portion, you take any value between minus infinity and minus 1 by 3. 0 lies here. So you take y equal to 0. So this will be 1 into minus 1, which is negative. So the expression is negative in this portion. So it will be positive in this portion and negative again in this portion. Okay. Therefore the solution will be y belongs to minus infinity to minus 1 by 3. Union 1 by 3 to infinity. Minus infinity and infinity are always taken as open interval because we can never achieve minus infinity or plus infinity. So minus infinity and plus infinity are always taken as open. Okay. So in this interval the function is undefined. But you see the value of y. Value of y is given as non-negative under root. So we will again write, but y is given to be non-negative. But y is given to be non-negative. So whenever the radical sign is there, that means it's a non-negative quantity. If the whole expression is under a radical sign, then the quantity is non-negative. So you have to leave the negative part, that means this part, and then only remains this part. So minus infinity to plus infinity and union the singletons at 0 also. Okay, singletons at 0. So we have to take the positive part. Okay, before that. So in this portion it is undefined. Therefore, the function is defined where in a closed interval minus 1 by 3 to plus 1 by 3. But it is undefined at 0 and 0 lies in this interval. So you have to leave 0 minus 0. Okay. In this portion the function is defined. Okay. But now you write y is given to be non-negative. Therefore, the range is you cannot take 0, so leaving 0 up to 0, this is undefined. Okay, given to be non-negative, so you cannot take negative. It is undefined at 0, so you cannot take 0. So it is defined in from just from the right side of 0 to 1 by 3. So the range is from open 0 to closed 1 by 3. Okay. Let us take one more example. Number 3. Fx equal to under root 4x minus x square minus 3. Let y equal to fx equal to under root 4x minus x square minus 3. So squaring. Whenever there is a square root, we will make square of both sides. Now you have to find the value of x here. Okay, so how to find? Let us form a quadratic equation. X square minus 4x plus 3 plus y square equal to 0. Now this is a quadratic equation in x. X square minus 4x. So ax square plus bx plus c. So a is 1, b is minus 4, and the whole thing is 3 plus y square is c. So what is the solution? Therefore x equal to minus b plus minus under root b square minus 4, a is 1, c divided by twice a. Okay. So this is 4 plus minus under root 16 minus 12 minus 4y square. Okay. 4x minus x square minus 3. 4x minus x square minus 3. Is that correct? 4x minus x square minus 3. Okay. Divided by 2. This is equal to 4 plus minus under root 4 minus 4 y square divided by 2. Okay. Now this quantity cannot be 0. This quantity cannot be, there is no root, so no question of negative. And here is a root. So this quantity may be undefined. So the function will be undefined whenever this expressed quantity is undefined. So we write, therefore, the given function is undefined. Function is undefined. Well, whenever this expression is undefined under root, so this, whenever this is negative, when 4 minus 4y square is less than 0. Okay. So divide by 4. 1 minus y square less than 0. Make y square positive. Y square minus 1 greater than 0. Sign changes, inequality changes. Now we factorize it. Y plus 1 into y minus 1 greater than 0. Now you find the zeros. So what are the zeros here? Minus 1 and 1. Okay. Now we have to check its sign in these intervals from minus infinity to minus 1 to 1, and 1 to infinity. Okay. So you know how to check. So you take any value in between minus 1, infinity, and minus 1. So let us take the value of y as 0. So this will be 1 into minus 1, which is a negative quantity. So the expression is negative here, then it is positive here, and negative here. But what is given? Greater than 0. That means positive. We have to find where the function is positive. So where is it positive? It is positive in minus 1 to plus 1 open interval. No equal to sign is there. So it will be open interval. This implies y belongs to, the solution is minus 1 to plus 1. Therefore the function is undefined in the interval minus 1 plus 1 open interval. So therefore the function is defined for y belongs to where? Leaving this interval, we'll get this interval and this interval. So minus infinity to minus 1 will be closed. Okay. In undefined portion, it is open, so it will be closed in the defined portion. Union closed, minus 1 is not included in the undefined portion, so it will be in the defined portion 1 to infinity. Okay, but a radical sign is here, so y is given to be non-negative. But y is given to be non-negative. Therefore, the range is, so leaving the negative portion, range will be this, closed 1 to infinity. Alright? Now let us solve one more example. Okay. You will learn defined things from defined examples. So go through all the examples. Okay. Our next example is, perhaps it is number 4. Fx equal to x square minus thrice x plus 2 divided by x square plus x minus 6. Solution. Let y equal to fx equal to x square minus thrice x plus 2 x square plus x minus 6. Okay. Okay. This is of the form polynomial by polynomial. X square minus thrice x plus 2 is a polynomial. X square plus x minus 6 is a polynomial. So this is of the form polynomial by polynomial. In this case, whenever fx is in the form of polynomial by polynomial, you are to check, if I factorize both the numerator and denominator, if there is any common factor, you have to cancel it out. Okay? So remember this, whenever given in the form of polynomial by polynomial, if there is any common factor between the two polynomials, you are to cancel it out. So let us factorize it. On factorization, this will be x minus 2 into x minus 1. Middle term factorize, you know it well. And this will be x plus 3 into x minus 2. So x minus 2 is a common factor. We are to cancel it. X minus 1 by x plus 3. Okay. But this cancellation is a conditional one. Okay. What is the condition? We cannot divide with 0. Cancellation means we have divided both numerator and denominator by the quantity x minus 2. And this cancellation will be invalid if x minus 2 becomes 0. So we have cancelled under the condition that x minus 2 is not 0. So here it is assumed that x minus 2 is not 0 means x is not 2. So we have cancelled it under the condition x is not 2. What happens if x becomes 2? We will discuss it later on. So let us cross multiply to find the value of x. xy plus 3y is equal to x minus 1. Okay. So thrice y plus 1 equal to x minus xy. Okay, this implies thrice y plus 1 equal to x into 1 minus y. This implies x equal to thrice y plus 1 by 1 minus y. Okay, no radical sign is here. So this will be undefined only when the denominator is 0, which is undefined. If the denominator is 0, that means what is the denominator here? 1 minus y. If 1 minus y equal to 0, then the function will be undefined. This implies y equal to 1. So the function becomes undefined whenever y takes a value 1. Now here you see we have left x equal to 2. We have considered x is not equal to 2, but we have to check what happens if x takes the value 2. So here we will check it. Now when x is equal to 2, when x takes the value 2, then y takes the value, see y equal to x minus 1 by x plus 3. So y takes the value 2 minus 1 by 2 plus 3. So 1 by 5. So when x takes the value 2, y takes the value 1 by 5. But x cannot take the value 2. X cannot take the value 2. Because when x takes the value 2, the value of y becomes undefined. That means the function becomes undefined. So x cannot take the value 2. That means y also cannot take the value 1 by 5. Because whenever x takes the value 2, y takes the value 1 by 5. So x cannot take the value 2, y cannot take the value 1 by 5. So the function is also undefined for y equal to 1 by 5. Okay. So at these 2 points the function is undefined. So the function is defined all over the real line except these 2 values. So what will be the range? Therefore the range is all the real values except 1 and 1 by 5. So within second bracket 1 and 1 by 5. So this is the range. This is another method. Okay, your approach should be decided depending upon the question. Which type of question you are facing? Okay, is it with square root? Is it with denominator? That will decide your action. Okay. So let us take the next example. Say this one. Perhaps fx equal to 1 by x into x minus 1. 1 by x into x minus 1. Solution. Let y equal to fx equal to 1 by x into x minus 1. Okay. So you cannot cancel anything here. Okay, because the numerator is 1, no x is there. So no question of cancellation. No question of common factor. Okay, so we are just to find the value of x from here. X square minus x. Okay, so you multiply x square y minus xy minus 1 equal to 0. This is a quadratic equation. So what is the value of a? A is y, b is minus y, and c is minus 1. So according to formula, therefore x equal to minus b plus minus under root b square minus 4, a is y and c is again minus 1 divided by twice y. Okay, this is equal to y plus minus under root y square plus 4y divided by twice y. So which is undefined? If this quantity is negative, y square plus 4y less than 0, and y is in the numerator, so it will again be undefined when y equal to 0. Okay, so factorize it. Y into y plus 4 less than 0 and y equal to 0. Okay. So what are the zeros of the polynomial? Y equal to 0 and y equal to minus 4. So the zeros are minus 4 and 0. Minus. So we have to check sign of this expression in these intervals. Okay, y into y plus 4. So in this part, minus infinity to minus 4. You take any value in the interval, say 0. 0 lies here, so you take 0. So 0, 0 will not do. Okay, 0 will not do. So on putting 0, it becomes 0. You are not getting any sign. So you put say minus into minus 4, say minus 5. Okay, minus 5 plus 4. Okay, so minus 5 into minus 1 is positive. So the expression is positive in this expression, in this interval. then negative in this interval, and again positive in this interval. So what is our sign? Negative. We have to find the interval where this expression is negative. So the expression is negative in the interval -4 to 0. Okay. Therefore, this implies, or you can take the solution as this implies y belongs to -4 to 0. -4 to 0. So this is an open interval -4 to 0. But 0 will be closed because y is taking the value 0 also. So 0 will be closed and -4 will be open. Is that clear? Why closed? No equal to sign is there, so it will be open. But y is also taking the value y equal to 0, so 0 will be closed. So what is the range? Therefore the range is r minus, in this interval the function is undefined, so you can write in this way also, r minus -4 to 0. Okay, just leaving the interval where the function is undefined from the real line, we will get the range. Okay, we are about to complete. Just one more example, a very simple example, the last one, perhaps 6 it is. Fx equal to 1 if x is rational and 0 if x is irrational. So what is the range? Range means the values of y for which the function is defined. What is y? Y is fx. So which values? Y has the values 1 and 0 only, no other value. Y has only the value, y means fx, and fx has only the value 1 and 0, it means y has only the value 1 and 0. So what is the range? Range is just 1 and 0. Clearly here the range is solution. Here the range is open set including 1 and 0. Okay. Now the homeworks. So in page 23, this is your homework. Class book, page 23, example 4. B, C, E, F. Then question number 11, then from class book, page 28, question number 11. You do all the sums. You do all the sums from question number 11. Then from NCERT, you solve. NCERT, exercise 2.3, from exercise 2.3, question number 4 and 5. Question number 4 and 5. Exercise miscellaneous. Okay. Then page 45. Example 19 and example 20. Then miscellaneous exercise. Miscellaneous complete exercise. Do all the sums from the miscellaneous exercise. Okay. Bye. From the next day we will start trigonometry. So those who had advanced in your HSLC, you go through the formulae that will help you, and note the homework. These are your homeworks. Okay, you note it.